Here is a problem which needs an elementary knowledge of differentiation and integration, that is your calculus. Problem is very simple, but it needs some basic knowledge. Do you know what exactly is the formula for the instantaneous power? Average power is different and instantaneous power is different. Average power is simply work done divided by time taken, whereas the instantaneous power is F dot V. Fine. So, let us read the problem and see how we can use it. A car of mass m starts from rest and accelerates with a constant power p delivered to it. The instantaneous velocity of the car is proportional to, right. So, this is proportional to, and a few options have been given. So, here he is talking about the instantaneous power. So, naturally the formula to be used is F dot V, but because the power is being delivered and the car is accelerating, you can take it for granted that the force and the velocity are in the same direction. Therefore, the car is accelerating with a continuous delivery of the power. Fine. So, let me write F dot V as F dot V, which is the instantaneous power, as m into A, and I will write A as dV by dt into V. Right. So, this is F dot V, and this is given to be P, and it is a constant. Now, you can just separate the variables and try to solve this differential equation as dV into V is P by m into dt. Fine. Now, if you integrate on both the sides, integration of V dV is P by m into integration of dt. Is that okay? So, now he has told you that the car starts from rest. So, at t equal to 0, you can take the velocity to be 0, the initial velocity to be 0, and at t equal to t, you can assume that the velocity has become v. Fine. Okay. So, now if you integrate this, you are going to get v square by 2, and if you integrate this, you are going to get t. Therefore, your expression becomes v square by 2 equal to p by m into t, or v square will be equal to 2p by m into t, and v will be equal to root of p by m, 2p by m into root of t. So, that makes the velocity proportional to, see, 2p by m and under root of 2p by m are constant. So, velocity is proportional to t raised to half. Yeah. So, that makes v proportional to root t, and hence C option is the correct option. There is a problem on conservation of momentum again, conservation of linear momentum. Yeah, let me read the problem. See, a man of mass 50 kg is standing in a gravity free space at height 10 meters above the floor. He throws a stone of mass 0.5 kg with 2 meters per second in the downward direction. By the time the stone reaches the floor, at what height will be the man? Right, that is the question given. See, it is a gravity free space which you are supposed to understand first. So, once there is no gravitational force, then I think the momentum in the vertical direction can be certainly conserved. Initially, the man along with the small stone in his hand both were at rest, therefore, the momentum was 0. He suddenly changes the momentum of the stone by throwing it in the downward direction, because of which his momentum is also supposed to change. But because he has changed the momentum of the stone in the downward direction, his momentum should change in the upward direction, because the net momentum has to be 0. So, the change in the momentum has to be 0. Therefore, if one of the momentums picked up by the stone is in the downward direction, the momentum picked up by the man should be in the upward direction. And then the stone which has been thrown by 2 meters per second speed has to travel a distance of 10 meters in order to reach the ground. So, I hope you agree that it is going to certainly take some time, and in that time he will start moving upwards and will have moved a fixed distance. But do not forget that he is already at 10 meters height, and if he moves further upwards, 9.9 cannot be the answer. So, then that makes only 10.1 and 20 to be the right options. Even 10 cannot be correct, because he was already at a height of 10 meters, and if he is going to move upwards, then certainly his height should be much more than 10. So, what we will do now is, of course, you can even discard a 20 also, saying that it cannot be so much, but still, now let us say that B and D are the options only left, which we will verify by conserving the momentum. So, how much has the momentum of the chalk changed? Mass into velocity, which is 0.5 into 2, which is nothing but only 1. So 1 is the change in the momentum of the stone. So by how much should the momentum of the man change? Also 1. So we will write 50 kg man having picked up a velocity of v0 should make 1, right? Therefore v0, the velocity picked up by the man, should be 1 by 50. So that will be the velocity of the man. And how much does the stone take with a speed of 2 meters per second to travel 10 meters? You can say S is equal to ut. Why didn't I use half 80 square there? Because let us not forget that the gravity free space has been provided, which means there is no acceleration of that stone which has been projected downwards. So it has to travel 10 meters, it has been projected with a speed of 2, therefore the time it takes will be 5 seconds. And in 5 seconds, even this man with a constant speed of 1 upon 50 is going to travel upwards. So the distance he travels will be again 1 by 50 into 5, which is nothing but 1 by 10 meters, and that is 0.1 meters. So he was already at a height of 10 meters, he has travelled a further distance of 0.1 meters, so that makes B option correct, and that is 10.1. So this is one more problem on conservation of momentum. But let me remind you that momentum is conserved only when there is no external force. See, internal forces do not change the momentum of the system. Only external force can change the momentum of the system. Let me read it and try to connect you people with the statement. Two particles initially at rest move towards each other under their mutual gravitational attraction. If their speeds are v and 2v at an instant, speed of the center of mass at that instant is. See, what is important in the question is, they were initially at rest. So when they are initially at rest and they start moving towards each other only under their mutual gravitational attraction, see here, mutual gravitational attraction is an internal force, and you know very well that internal force should not change the momentum of the system. So if initially the momentum of the system was 0 because the particles were at rest, no matter, even if they start moving towards each other, picking up different velocities, their masses are different, whatever, the external force is absent, therefore the momentum has to always remain 0. And if the always momentum remains 0, then what would be the velocity of the center of mass? It should be 0. So the right option here is 0. This is a problem on conservation of momentum again. So let us read the problem. An explosion blows a rocket into 3 parts. 2 of the masses are 1 kg and 2 kg, and they are moving with velocities 12 meters per second and 8 meters per second at right angles. The third one has got a velocity of 4 meters per second. What would be its mass is the question. So what you can understand here is, the explosion has happened and then the rocket has broken down into 3 parts. So initially the momentum was 0 because the rocket was at rest. So finally also the momentum has to be 0. These two have moved at right angles to each other. So if you consider their velocities to be along x-axis and y-axis, you can write the conservation of momentum as 0 equal to 1 into 12 I cap plus 2 into 8 j cap plus m into x I cap plus y j cap to be equal to 0. Did you follow this? X I cap plus y j cap is how I have written the velocity of 4 meters per second, because I want the total momentum to be 0. So unless the third particle has got a velocity in both the directions, the net momentum cannot become 0. Okay, so now if you simplify this, you get mx equal to minus 12 and my equal to minus 16. So if you square them and add them, you get m square into bracket x square plus y square as 12 square, which is 144, plus 16 square, which is 256, which makes it 400. So that makes it m square into 4 square is equal to 400, because the square of the components of these two should give you the square of the velocity of the third particle. This makes m square is equal to 400 divided by 16, which makes it m equal to 20 by 4. So, m will be equal to 5 kg, and that makes the answer as D.